Imagine you are an astronaut on a spacewalk, hundreds of thousands of miles from Earth's magnetic shield. Without warning, a burst of solar radiation erupts, sending high-energy particles towards your body from a single direction. This is the reality for astronauts today who conduct EVAs beyond Earth's magnetic protection, where this exposure is directly linked to increased risk of fatal cancer. Beyond Earth's magnetic field, radiation becomes one of the most dangerous constraints on human exploration. Astronauts can experience radiation levels up to 100 times higher than on Earth. Some radiation builds risk long-term, but other forms can deliver dangerous doses within hours. These acute events, called solar particle events, are frequent, directional, and unpredictable. Yet, today's spacesuits rely on static, uniform shielding, designed as if radiation comes equally from all directions and adding unnecessary shielding mass to the astronaut's body. That mismatch puts astronauts at risk and limits how far and how long humans can explore. This is not sustainable. Introducing Vital AEGIS. AEGIS is an adaptive, AI-powered radiation protection wearable subsystem designed to solve this problem at the astronaut level. Instead of adding more shielding all around the astronaut's inner suit, increasing mass, and risking harm and discomfort to the astronauts, AEGIS intelligently determines when radiation risk increases and where it is coming from, and then dynamically redirects our custom anti-SPE radiation gel in real time. This changes radiation protection from static material that astronauts have to endure into an adaptive system that actively defends them when exposure becomes life-threatening.
AEGIS integrates three core technologies. First, distributed radiation sensors embedded around the suit continuously measure radiation intensity across multiple points. By comparing these readings, the system infers the direction and strength of incoming radiation. Second, this data combines with NASA series radiation data and feeds into a control system informed by our predictive AI, which analyzes real-time conditions and radiation patterns to proactively anticipate elevated radiation risk. Third, our adaptive shielding gel embedded within the suit redistributes dynamically, concentrating protection toward the highest risk exposure vector instead of remaining uniformly fixed. Our signature adaptive material is a boron-infused hydrogel lightly wrapped in a layer of ultra-high molecular weight polyethylene, which effectively distinguishes up to more than 40% of radiation than current solutions like Astrorad.
Without adaptive protection, astronauts operating beyond Earth's magnetosphere face a highly variable radiation environment. Solar particle events can rapidly elevate dose rates over short time windows, while continuous exposure to galactic cosmic radiation contributes to long-term health risks, including increased cancer probability and potential neurological and hematopoietic impacts. Current suit-level protection relies on static, uniformly distributed shielding, which assumes radiation arrives equally from all directions. This one-size-fits-all strategy protects low-risk regions, while underprotecting the dominant exposure vector, creating both safety and performance trade-offs during EVA. With Vital AEGIS, shielding is dynamically concentrated where radiation is actually coming from. This reduces peak dose exposure during SPEs, lowers cumulative radiation burden over time, and improves EVA safety margins without increasing suit mass.
We are currently in the prototyping stage of building AEGIS. This is version 1. This prototype demonstrates the core AEGIS system operating as an integrated whole. Directional radiation conditions are modeled to evaluate system behavior across a range of exposure scenarios. As sensor readings vary spatially, the control system processes the data in real time and actively redistributes shielding toward the highest risk exposure vector. Building on these results, we are advancing to a version 2 design focused on increasing precision, improving response time, and refining physical integration for mission-ready constraints. AEGIS is designed as a licensable subsystem, integrating into existing spacesuit architectures rather than replacing them. This reduces adoption friction while scaling across government and commercial missions. If humanity is serious about sustained deep space missions, radiation protection cannot remain passive. It must become adaptive. So join us at Vital as we make the next frontier of human spaceflight and exploration possible.